Welcome back to The Explainer, everyone. I'm your host, Dr. Chem. Today, we're stepping out of the laboratory and straight into the field to totally demystify the science of active composting. For way too long, we've kind of just looked at this as a slow, passive process, just a pile of rotting yard waste, right? Well, today, we're putting that pile under the microscope. We're going to see how you can transform it into a finely tuned, environmentally sustainable biological engine.
Seriously? Listen to this incredible quote from How to with Doc. 18 hours, 130 degrees. That is absolutely crazy, dude. I mean, think about it. If we pointed a thermal camera at this pile, it would literally be glowing red. The takeaway here is that with the right inputs, your compost isn't just sitting there. It becomes a fast, actively firing thermal engine, literally overnight.
So here's our roadmap for today's explainer. We're going to hit the fast composting miracle, the golden C to N ratio, perfecting compost moisture, supercharging with minerals, and finally, testing your finished compost. Let's get right into it.
Section 1. The Fast Composting Miracle.
To fire up this miracle, we really need to shift our mindset. Imagine we're zooming way in, right down to the microscopic level of your pile. The beneficial bacteria and fungi, they're essentially your hard-working biological chefs. But they demand 4 very specific inputs to do their job: clean organic matter, proper moisture, oxygen, and an initial microbial spark, something like chicken crumples. If you deprive those microbes of even one of these elements, the entire biological system just shuts down completely.
Section 2. The golden C to N ratio.
Okay, so now that we know what fires up the engine, we really need to examine the fuel. And that brings us to the C to N ratio. This is simply the exact proportion of carbon to nitrogen in your materials. See, microbes need carbon for their energy, and they need nitrogen to synthesize proteins. And the research shows us that their absolute perfect diet falls right between 25 to 1 and 35 to 1. When you hit that sweet spot, you maximize microbial growth. And as a huge bonus, you totally prevent those nasty, foul ammonia odors. To actually hit that golden ratio out in the field, we have to layer our elements. On one side, we've got our greens. These are your wet, nitrogen-rich fuels, things like poultry litter or fresh grass clippings. On the exact opposite side, we have our browns. These are the dry, carbon-rich structural pieces, like dead leaves and shredded paper. When you balance those fast-burning greens with your slow-burning browns, you're building the ultimate microbial fuel cell. Moving on to Section 3, perfecting compost moisture. You can think of moisture as the vital motor oil of your compost engine. If there's too little, the engine seizes up. Too much, and it floods. So how do we get it just right? Well, out in the field, we use a brilliant method from the LSU Ag Center called the squeeze test. It's super simple. You just reach deep, like 18 to 24 inches, right into the center of the pile, grab a handful of that organic matter, and squeeze it really tight in your fist. What we're aiming for here is an exact 45 to 60% humidity level. Let's do a quick side-by-side comparison here. In a perfectly optimal state, the compost should feel tacky. It sticks together in your hand, maybe with a slight sheen to it. That means you have perfect aerobic moisture. But contrast that with the alternative. Say you squeeze it and a literal stream of water pours out, leaving you with this muddy, pudding-like sludge. That pile is sitting at over 75% moisture. It is literally drowning, it's turning anaerobic, and all those good microbes are dying off. So, what do you do if your pile is drowning? You've got to act fast to restrict the water. Throw a tarp over it immediately. Inject some dry, bulky browns like straw to absorb all that excess moisture, and grab a pitchfork to physically turn the pile so you can force oxygen back into the system. On the flip side, if it's bone dry and dusty, you'll want to layer in some high-water veggies or fresh grass and give it a good misting with the hose while you turn it. Section 4. Supercharging with minerals. All right, once you have those basics totally dialed in, we can really start having fun and supercharging the system. Just look at this mind-blowing data from Peshawar University. They recorded a massive 928.6% increase in plant-available phosphorus. How? By combining poultry litter with locked-up rock phosphate and effective microorganisms. It triggers this totally fascinating reaction. The organic acids produced by the microbes actually dissolve the solid rock, completely unlocking a massive payload of highly bioavailable nutrients straight into your soil. It's like biological magic. And if we were to run a time lapse of this entire process over, say, 120 days, the data is just striking. You'll see the total organic carbon steadily plummet as our microscopic chefs rapidly consume and cycle through all those carbon structures. And what they leave behind is this incredibly stable, hyperpotent biological fuel.
bringing us to Section 5, testing your finished compost.
So, months go by, the pile's volume has significantly shrunk, and everything looks dark and crumbly. Awesome. But before we even think about introducing this to our precious crops, we absolutely must test it. The very first diagnostic we run is the Living Farms overnight bag test. Just take a few cups of your compost, seal it up in a plastic bag, and let it sit for 24 hours. When you open it, take a big whiff. If you get a rich, earthy aroma, you're good to go. But if you get hit with a sharp, stinging ammonia smell, that means there is still unprocessed nitrogen in there. Your engine is still burning, and it needs more time.
Now, if it passes the smell test, we graduate to a controlled seedling test to visually gauge the potency. We basically pit two different subjects against each other using your new compost. On one side, we plant heavy-feeding tomato seeds. They demand massive amounts of nutrients. On the other side, we plant delicate green bean seeds, which are highly sensitive to nitrogen burn.
The visual results after just a few weeks will literally tell you everything you need to know. In mature, mild compost, both seedlings will boast lush, beautiful green growth and really strong root structures. But if your compost is still hot and chemically volatile, those sensitive bean roots are going to look totally scorched and stunted. Trust me, you always want to test before you spread.
Because ultimately, this dark, crumbly, nutrient-dense material is our absolute end goal. By engineering that perfect 30-to-1 ratio, meticulously maintaining your 50% moisture, and cultivating the right biology, you are literally transforming basic yard and kitchen waste into black gold. It drastically reduces landfill use and breathes vibrant life right back into depleted soils.
So I'm going to leave you with this one thought. Are you still running a passive, rotting garbage heap in the back corner of your yard? Or are you ready to upgrade and engineer an optimized, environmentally sustainable compost engine? The biology is out there waiting for you. You just have to follow the recipe. I'm Dr. Chem, thanking you so much for joining me for this explainer. Keep experimenting out there, and I'll see you next time.